When the U.S. military recognized the need to switch their primary AI providers, they mapped out a meticulous 6-month timeline to guarantee a seamless transition across their operations. If your enterprise's primary AI vendor suddenly terminated service tomorrow, you wouldn't get 6 months. You would get 0 days of notice to rebuild the core engines running your company. This vulnerability exposes the anthropic effect, the catastrophic fallout when an organization realizes its critical operations are running on infrastructure it doesn't control, can't replace quickly, and has never tested against an alternative. If that central provider goes dark, whether from regulatory blacklisting or an unexpected vendor failure, your automated workflows, customer service pipelines, and internal reasoning engines don't degrade, they stop completely. Despite relying on these systems for critical operations, the vast majority of organizations are building on infrastructure they do not control, and they have never stress-tested a viable backup. When enterprise leadership teams attempt to address this exact risk, they usually frame it around the concept of digital sovereignty. Historically, the C-suite treats this concept as a defensive exercise. It gets delegated to legal departments to ensure checkboxes are ticked for local privacy laws. In this traditional framework, enforcing strict rules about where data lives and who controls the server is viewed as friction, a necessary annoyance that slows down technological adoption. But that perspective gets the math backwards. Enforcing strict boundaries around your technology stack is the only structural method to guarantee you don't become permanently trapped in a single vendor's ecosystem. Digital sovereignty provides the foundational architecture for strategic optionality, using technical control to preserve a company's freedom to move. Consider the cloud migration strategy of Scania IT, the division managing logistics and production systems for the global truck manufacturer. They identified the temptation that catches most enterprises. Moving entirely into a single hyperscale cloud provider offers immediate access to massive compute power and rapid global deployment. Building deeply inside one proprietary environment creates structural dependency. The tools that make initial adoption so fast also weave the vendor's specific code into the DNA of your operations. The first trap is portability. When you need to move your raw data to a competing service, you suddenly encounter exorbitant egress fees and proprietary storage formats designed to make leaving prohibitively expensive. The second constraint is interoperability. The custom applications you built lose their ability to communicate with external tools because they are hard-coded to the specific APIs of that vendor's walled garden. The third layer of lock-in is federation. Your entire system for user identity, security, and access controls becomes tethered exclusively to the provider's ecosystem, making it impossible to authenticate your own employees outside their platform. These architectural anchors remain invisible while a project is small. They reveal themselves later, usually when the enterprise attempts to expand into a new jurisdiction with different data laws. The faster an organization scales its capabilities inside a closed environment, the higher the financial penalty will be when they are eventually forced to migrate. To prevent this trap, the AccessSync AI Optionality framework deconstructs the enterprise IT stack into 5 distinct layers. At the base is the compute ecosystem. If your operations rely exclusively on a specific proprietary GPU architecture, your performance limits and cost structures are entirely bound to that hardware manufacturer's supply chain. Next is the cloud platform layer. Relying on provider-specific management tools eliminates your operational elasticity, making it impossible to spin up identical instances on a competitor's server. The third tier governs AI model ecosystems. Organizations have to navigate the tension between renting powerful proprietary models and developing open-source alternatives that they actually own.
Above that is data architecture. Maintaining strict separation between your core data and the application layer is a firm prerequisite. If your data is independent, you can seamlessly swap out the underlying AI models without retraining your entire system. The top tier encompasses the regulatory environment. A truly modular stack allows you to meet different global privacy and sovereignty requirements by adjusting local configurations, rather than tearing down the entire infrastructure. The advisory firm Kyndryl structures this approach by requiring executives to define their exact operational needs and acceptable trade-offs long before evaluating any specific vendor systems. This strategy requires a shift away from manually configuring individual servers, moving instead toward automated, environment-agnostic deployment, where infrastructure is entirely modular. In engineering terms, this methodology is called infrastructure as code.
Infrastructure as code allows an enterprise to execute a precise hybrid strategy. Highly sensitive data can run entirely on internal, sovereign clouds, while non-critical workloads are routed to external hyperscalers to save money. By treating sovereignty as a process of continuous modernization through modular design, compliance requirements stop being a roadblock and instead drive operational agility. Experts at Cisco note that this architectural discipline is about to become mandatory as the industry pivots toward agentic AI, autonomous systems designed to reason through tasks and execute actions across enterprise networks without human input. This shift engages Conway's law, the principle that an organization's software design inevitably mirrors its internal communication structure. Yesterday's systems relied on rigid API contracts. Multi-agent networks use natural language as a fluid, dynamic schema to interpret commands and write code on the fly. To function effectively, this emerging Internet of Agents requires distinct software components to collaborate across completely different organizations, locations, and cloud providers. The sheer scale of this cross-vendor reality is visible in the Linux Foundation's AgentTC project. These autonomous agents have no shared memory and entirely different access controls, yet they still have to seamlessly negotiate shared intent across network boundaries. This requires a zero-trust sovereignty framework. You cannot grant an autonomous algorithmic agent implicit trust to execute functions on your network, allowing these AI agents to operate strictly within authorized parameters. If you deploy agentic AI without first engineering a deliberate, zero-trust sovereign infrastructure, it stops being a competitive advantage and becomes an uncontrollable liability. Consider two different enterprises facing the exact same sudden shift in global data regulations or a major disruption in vendor availability. The monolithic enterprise, locked deep within a single provider, will halt operations as engineers scramble to manually untangle hard-coded, non-compliant data pipelines. The modular enterprise, utilizing infrastructure as code, will simply repoint its environment, fluidly swapping out its compute and model layers to meet the new requirement without dropping operational speed. In this architecture, digital sovereignty acts as the engine of strategic optionality, ensuring the organization maintains custodianship over its own future. Unrestrained adoption without architectural control creates a structural dependency that cedes ultimate decision-making power to external vendors. The enterprise that dominates the market will not be the one that manages to select the fastest AI model today. The winner will be the enterprise that deliberately architects its foundational infrastructure to easily adopt the fastest AI model of tomorrow. The systems we build today dictate the freedom we retain tomorrow.